It is my humble privilege to introduce today's speaker, Professor Amarjyoti Choudhury. Sir, it is a difficult task to summarize the contributions and achievements of a personality such as yours in 5 minutes. You have done so much that you are a household name of almost every house in Assam, as well as many parts of the world. Still, I will try to do my best. Professor Amarjyoti Choudhury is a distinguished educationist, scientist, actor, reciter, playwright, poet, novelist, and orator from Assam. He was the former Vice Chancellor of Guwahati University and former Pro-Vice Chancellor of Tezpur University. He later occupied the C.V. Raman Chair of Applied Physics of University of Science and Technology in Meghalaya and also became the Vice Chancellor of the same university. Currently, he is the Vice Chancellor of Assam Downtown University. He has a brilliant academic career. A graduate with honors in physics from Guwahati University, he did his master's in physics from Delhi University. He then got his doctorate degree from University of Oxford, England. He has taught in a number of institutes all over the country. He has acted as visiting professor to European Laboratory for Nonlinear Spectroscopy, Italy, and later in Inter-University Accelerator Center, IUAC, New Delhi. He has collaborated with P.N. Lebedev Institute, Moscow, University of Southampton, UK, and Polytechnic University of Bucharest, Romania. He has been an active researcher in optics, quantum electronics, condensed matter physics, nanophotonics, and nanotechnology. He is credited with 148 research publications in peer-reviewed national and international journals and has guided 20 PhD scholars till date. Today, high-end research in physics, chemistry, life science, etc. cannot do without an instrument called the confocal microscope. We are indeed very proud to be sharing this room with a very person, Professor Amarjyoti Choudhury, who along with his supervisor, Professor C.J.R. Shepherd, are credited to have been the key persons behind the idea of confocal microscope. Professor Choudhury is also well known as a popular author on scientific topics in local newspapers and magazines. He has translated 3 books for National Book Trust from English to Assamese, namely Ramanujan, Satyendranath Bose, and The Shrinking Universe. He has also authored a book on nanotechnology. Professor Choudhury also shines in the field of culture, literature, and performing arts. His trilogy of plays titled Hoyer, Tony Kora, Tora, etc. are a few examples of his brilliance. His recent novels in Assamese, namely Gosor Nisina Hakukhon and Road Kakolir Manu, have become very popular. We are indeed lucky today to get this opportunity to listen to you, sir, as you will be talking on the life and work of another personality, Professor Hawking. Thank you.
Yes, esteemed Vice Chancellor of Tezpur University, Head of the Department of Physics, and other departments, sister departments of this university, faculty members, members of administration, and my dear student friends. It's like homecoming to Tezpur University. Thank you, Professor Gaji, for introducing me. But I have come with the intention of doing an obituary cum tribute to a great scientist, Professor Stephen William Hawking. Then the way I was introduced, I was feeling like as if my obituary was being read out. Now we all know the films and plays are normally exaggerations of life. They do not actually represent life. But then the film Theory of Everything, which was on the life of Stephen Hawking, we all know, and it has been certified by the person himself, Stephen Hawking, that it was very, very close to the original. What happened to Stephen Hawking's life? So I do not know whether it has been screened in this university, but then if it has not been done so far, then I would request the head of the Department of Physics to kindly screen it for the students, because it shows not only his life but also his work. Now, Eddie Redmayne, who played the role of Stephen Hawking in the film Theory of Everything, he read out from Bible when the funeral of Stephen Hawking was done last Saturday, that is April 30th. There he read out from special part of the book of the Bible called Ecclesiastes, and the meaning and the book, if we can summarize, it comes out in the first 2 or 3 lines, and it says, to everything there is a time, to everything there is a time, there is a season, there is a time to be born, there is a time to die, there is a time to weep, there is a time to laugh, there is a time to weep, there is a time to cry, there is a time to mourn and time to dance. So if there is a particular time for everything, then as a student of science, very often this thing comes to my mind, that when is the time when we know that the society accords greatness to some person. What is that particular time? There could be many occasions, but then one specific time is the funeral. In the funeral, those who are esteemed, those who are in high esteem or revered, we find that there are numerous people. And in case of Stephen Hawking, we have seen a totally unprecedented scene, because normally, if I happen to study in England, so I know that in England, in funerals, normally the average attendance is about 20, 30 or 40. That is the range. Even for great scientists, this is the range. I have seen great professors of Oxford University, death, and I have attended personally, but then number is limited to that. It is for the first time that a scientist who is admired, and in his funeral we have seen people lining in the streets of Cambridge as if he was a rock star. So this kind of adulation to scientists was never seen before, and this has come because of a number of reasons, because of the cult status that was given to him. Cult status like I remember he came to Oxford University in 1976. That time he had just done the Hawking radiation, and even then he was like a star, and the hall was full. We had to stand outside to listen to him. So this is the kind of, so we are talking about an exceptional person, Stephen Hawking, and today we would like to talk about his life and also his ideas, his thoughts, his works in terms of the universe that he created on his own, and it's mostly in the form of a tribute. Your next slide, please. So this is the one.
This is the pointer. This one will come back and forth.
I can go to next one.
This is the pointer.
Yeah.
This is the next one. This is the next one. Yes.
Yeah. So abstract is the talk will highlight the extraordinary life and works of this great scientist of the century, and who passed away on March 14 in the form of a tribute. So we are here to pay tribute to an exceptional person, as I said, exceptional person, which has been more or less denoted by his funeral. And but he said, why we are special? He said that we are in an advanced breed of monkeys. Look at the kind of words he has used. We are just an advanced breed of monkeys on a minor planet. Earth is a very minor planet, if we think of the universe, of a very average star. Our star is very average if we think about its size. So, being an inhabitant of a minor planet, and that too of an average star, we all are. But then we can understand the universe, even staying within this finiteness of space. That makes us very special. That is what he said. I think we can use the same words to him and to say that why Hawking was very, very special, extra special. Next one. Oh, I think I have to do it. So my question, if he is not extra special or extraordinary, then who he is? We all agree he carried his mission to a new height. What are his heights we'll talk about in a few minutes' time. But he was a man who was confined to the wheelchair for most of his life, who could hardly move his finger. Only one finger he could move, and one part of his eyelid, and that too not the full. So this was the man. He could not move other parts of the body, only one finger, one eyelid. And that too, when the disease took hold of him, he was mere 22. He was just doing PhD. He was just in the first year of his PhD program. And he was a mere nobody then. Nobody knew about Stephen Hawking. And he was only showing occasional brilliance because he was talking too much about singularities, propping up new questions to his supervisor, which surprised the supervisor too. But then, and also doctors at that period gave him time only for 2 years of life. So these were the setbacks against which he had to work, but he emerged as a front-ranking scientist from there. Normally, we have seen that people under these circumstances even go to the extent of taking their own lives out of depression. But he was someone who overcame this trauma to lead a life full of fun and humor. And if it is not special, what it is? If he is not special, who is? On top of that, he announced that yes, I cannot move, and I have to speak to a computer. That is what he said. But in my mind, I am free. Free, and when he used this word free, he used to demonstrate it physically, in the sense that he traveled to different parts of the globe, although he was confined to globe, and never he did allow the physical disabilities to come on the way. Indeed, it was this immensely free mind of the man who gave us more comprehensive understanding of nature, understanding of the universe. So it was he who gave us vision that universe had a beginning. We will talk about it. That black holes give out radiations, which we will talk about it later. And how can we deny that this person was extraordinary? What is equally amazing that he had a career at all, because as I said, doctors gave him just 2 years of life, but he learned he had amyotrophic lateral sclerosis. That is the disease. It's a disease, crippling disease that cripples the nerves, cripples the spine, and cripples all the parts, different parts, nerves and veins, gradually. And disease reduced his bodily control of the flexing of a fixed finger and voluntary eye movements, but fortunately left his mental faculties untouched. How it was done, it is still a mystery. Yet he went on to become generation's leader in exposing the gravity and properties of black holes, and that is the extra speciality of this person. So we say he's a hero in the League of the Greats. Why? Because Hawking liked to point out that he was born 300 years exactly to the day after when Galileo was born. And he died on March 14, as we know, the birthday of great scientist Albert Einstein in physics. Like Einstein and Galileo, he also worked on gravity. And in popular praise, he was always referred to as the greatest physicist since Einstein. He dismissed it, he for himself dismissed it as a media hype, and he said that all generations need a hero, and he was simply made a hero because he had this crippled life. Truly, his life was Einsteinian, just like Einstein came from almost nowhere and was almost not coming from the university or great research laboratory for that matter, but it changed the course of physics. Similarly, was the case with him, although he was right there in the University of Cambridge. And he was a hero not only because he gave us new ideas, but also because the way he lived. We have seen him, as I said, I remember the lecture he gave in 1976 at Oxford University. We had to stand outside, as I have said, because there were too much of people in the hall. But the way he spoke, at that time his voice was not metallic, he could speak, and the ideas he proposed and the way he spoke made things so simple. Difficult ideas of physics that he made so simple were just enormous. Look at his act of defiance in spite of his difficulties, disabilities. For example, he married twice. He fathered 3 children. He wrote bestsellers on science. Until then, bestsellers were not coming. But his book, Brief History of Time, that sold 10 million copies instantly. Guided generations of research scholars, roamed the world. He moved from one part of the world to another to give lectures. And there, whenever he went for these type of lectures, he always used to speak in a common man's language. That was another strange thing. When he went to a conference per se, then his ideas would be spelled out in abstract, most abstract ideas of mathematics, which most of the people fail to appreciate. But then when he went for these popular lectures, he used to speak totally in common man's language and roamed the universe in his mind, thought about the whole universe, combined relativity and quantum mechanics. These are 2 different ideas. Relativity and making it consistent with quantum mechanics is very difficult because there are many infinite terms appear and you do not know what to give a meaning of these infinities. But then he used a method whereby he could remove most of the infinities and come to very specific conclusions which we will talk about. So how can we not salute this person? We have to salute this person in absolute admiration. And Michio Kaku, the noted scientist, theoretical physicist, that's why he said, not since Albert Einstein has a scientist who captured the public imagination and endeared himself to tens of millions of people around the world. And we all know he did it through his book, A Brief History of Time, which sold more than 10 million copies, and the feature film which was made on him, The Theory of Everything, that was also a total hit. If we look for the essence of the man, it was the works on gravity that set him apart. So if we ask, what work in precisely that sets him apart, he did a number of things. But then it is mostly the work on gravity that made him apart. It appears that a tribute to him would be incomplete without an effort to appreciate his works which he said makes us special and which made him special. So we will talk about gravity. And so let us roam through the ideas that are so close to his heart, the ideas of gravity. And we propose to do it not through mathematics. For the first time, I'm also trying to use common man's language in tribute to this great person, so that we understand what is gravity, what is black hole, without referring to mathematics per se. Because I'm told this is a talk meant for general people, that is from all across the disciplines. Now, why cosmology? Why did he study cosmology? That is the origin of the universe. Because he said, there are many things he said, but the last line, this I mean, because he says cosmology now answers many questions one asked of the religion. So he could answer those questions. For example, how the universe began. Okay? But what in cosmology? For example, he used to like questions which has pondered mankind has pondered over the centuries and centuries. For example, we know in Rig Veda there is a portion called Nasadiya Sukta. Okay, this creation Sukta it is called, and it says there was the first line goes like this. I will read out in English that there was neither existence nor non-existence. Who covered it? Wherefrom? There was not even time, there was not even space, there was not even sky. Who covered it? Was it in abyss of waters? These were the questions pondered by those persons in Rig Veda. Although I would not never claim, as many people would like to do, that in the Rig Veda itself we have all the answers. That is not quite true. But then yes, the questions were raised, and similar questions were raised by Stephen Hawking too. Now, coming to gravity. As I promised, I will begin from the beginning. And here is this, I think students will know whose picture is this. Students of physics. Isaac Newton. Isaac Newton, the person who is so much admired by one gentleman in our Department of Physics, Professor Jayanta Kumar Sharma, who has translated his book Principia. Okay, now coming back to gravity, we know that how does it work? According to Newton, that if there are two masses, one here, then there will be a force of attraction, and the amount is proportional to the mass of this one, and it is inversely proportional to distance. That means the more the distance is, the force will decrease, or if we bring it closer, force will increase. That is and there is a constant involving we call it gravitational constant, and we all know that as students of physics we are required to determine it in our laboratory. Now, gravity is normally called the weakest of forces. Why is it called so? Because everything is relative. But why is gravity called weakest of forces? For example, if we have two protons, one here and one here, 1 centimeter apart, then if we count the force of gravitation between these two particles, protons, that is 10 to the power minus 57 newtons. But if we measure the electric charge, the force due to electric charge, the proton has got plus one charge. So what is the interaction between the force of repulsion? That is given as 10 to the power minus 24. So that means the force of gravity is 10 to the power 33 times smaller or weaker as compared to gravitation. So that is why, if it is smaller, so that is why we say gravitational force is so weak normally. But then what happens when gravitation is strong? And this was the question posed by Einstein. This was the question posed, and where this gentleman called Stephen Hawking went more deep into it. Now, coming back to stars, without referring to stars, Hawking's works are incomplete. Any reference to his work would be incomplete. That is why we need to understand this. Normally, a star would collapse because of its mass, heavy mass, because everything is pulling it down because of gravity. So, because of gravity, it should have fallen down. Then why is it there? Why is it not falling down? We all know that it is because of the fusion of hydrogen atoms into helium, which is giving enough energy so that there is expansion. So there is force of expansion because of fusion, and there is force of pulling down because of gravity, and there is a balance, and it is because of this balance stars stay as it is. So we say that in stars the forces caused by nuclear fusion and gravity balance each other, and this is known as hydrostatic equilibrium for stars. Now Einstein's view of gravity. We are collecting material so that we can appreciate Hawking's work. Now, if we think about gravity, we all know that Einstein through relativity gave us the idea that space and time are equivalent, that they are equivalent coordinates, that they have equal identity more or less, and that they are on the same footing. And space time we should consider together. Space and time we should consider together. I think all physics students know it from relativity. Now, suppose we take a slice of space like this, and then we put something heavy on it. What will happen? This portion bends. Yes? I'm asking student friends. Yes? Yes. So, Einstein showed through mathematics that this indeed is the case. Whenever there is a mass somewhere around, the fabric of space-time, it bends like this. It bends like this. Now, think of a very heavy mass nearby. It will bend more. Think of a still heavy mass. It will bend more, until only a small hole is left, like this. Then everything is enclosed within this. Yes? Because gravity is making almost a closed structure. Nothing can come out of it, not even light. So this is the ultimate concept of black hole, that gravity bends, and when there is a much mass which is heavy, then it bends further until it bends to a point where there is only a small hole, and the rest of the things are totally under the act of gravity, nothing else, pure gravity, and this is the strongest portion of gravity, and that is how black holes emerge. But there in between there are few processes. We know about red giants. We have to understand red giant and then white dwarf and the neutron star to appreciate black hole. These are the different stages of stars. Red giant star is when, so we have been telling you that hydrogen and because of fusion of hydrogen atoms into helium in the stars, there is a force, expanding force in the star which is going out. Now think of a situation where all the hydrogen atoms in the core is depleted. Then what will happen? Then this force for expansion is no longer there, but the force of pulling it down is there. So inside the core will come under the influence of gravity, and it will be pulled and pulled. But there could be some hydrogen atoms in the outer spheres, just outside this core. In that case, what will happen? So from there now the fusion will take place, and again the star will expand. And sometimes it expands to a size which is about 400 times the size of the star. And it looks red because it is hot, but not very hot. Hot in terms of, if we think about our human experience, it is very hot, but then not the hottest. So now it becomes red, becomes 400 times the mass of the size of the sun, for example, and it is also going to happen to our sun. At one point of time, our sun will also become a red giant, and our Earth is going to be consumed. Only grace point is that it is years and years, millions of years away. But then at some point of time, Earth will be consumed by the sun. So, a red giant is there. Then what is white dwarf? White dwarf is now, because of the expansion, it has become red, and gradually suppose all the hydrogen atoms are done with, that is, they have been fused. Then it will go to helium atoms, will go to make carbon atoms. That process will start. After that, only there will be carbon atoms left. But then to make fusion of carbon atoms, you need huge increase in temperature. That temperature cannot be, is not available in the atmosphere, I mean in the interior of the star anymore, because other things are already exhausted. So because of that, this portion will now cool down, and because there is only small amount of, some of the mass will already go away and the rest of the mass will fall back to that core, which will be now white hot because so much of mass has come to the interior that it becomes white hot. That is why white dwarf comes. No. Carbon normally carbon will not come. What I am saying that helium atoms will fuse together to give higher molecules, and at one point of time they will also generate carbons. But even, I mean, and some other atoms they will produce in the matter. But normally you will see that after that there will not be enough energy to create fusion within this system anymore. So that is why. So this is the image of Sirius A and Sirius B taken by Hubble Space Telescope of Sirius B, which is a white dwarf, can be seen as a point of light because it becomes very faint as it times goes on. Then there is a neutron star. Neutron star is something like this, that normally if we think about our two hands and suppose I press my hand across the other hand, then I can press it only up to a certain point, not beyond. We know that there are holes inside this. My hands, I have got number of holes inside it, and here also same thing. But then even in spite of that, this hand cannot go inside this and come out for that matter. Why is it so? Because there are electromagnetic forces coming into play if we make the distance very small, and these then will be these electromagnetic forces will now repel each other. So that is the case of normal cases. But when the gravity is very high, it will so happen that they will crush these electrons and protons that we normally have, and all of these will gradually turn into neutron. So these are the case of neutron stars, and with these there are in the process it has got magnetic fields trillions of times stronger than Earth, because they rotate extremely. I mean, these neutron stars keep on rotating and beam radio waves in cones which periodically sweep across the Earth, and these are called pulsars. So pulsars are very typical of neutron stars. Most of the neutron stars are pulsars and they emit X-rays. And finally, if it is stronger than, if the gravity, because now once this act of gravity starts, it will keep on pulling down, like our Hindi films when we see a person hitting, he is hitting again and again. So similarly, this gravity will also keep on punching and gradually bringing it down, and ultimately we will get black holes. So that is the ultimate stage of the, so this is the black hole. We can think of this in like this, that you can have a star like this. So from star light will come out normally, but because we said that that if it becomes heavy, the stars become heavy, then if it is a medium size neutron star, then it will slightly bend, light will slightly bend like this. This is a straight, so there is some amount of bending. If it is a neutron star which is somewhat massive in comparison with this, it will bend further. But it's a black hole, it is so massive that all the lights come back to itself like this, it bends. The space itself is bent, all the roads are bent. So cars, if we think light like cars, so the cars have to come through these paths and they cannot go out. So this is roughly the idea of black hole. So black hole that way is a perfect prison, because what is the concept of a prison? That you do not allow anybody to come out of it. So here is a prison which does not even allow light to come out of it. Light is supposed to be the trickiest of all, because you cannot hold back. Can you hold this light back? It is not possible. So, but then gravity when becomes so strong, it does not allow even lights to come out. So that is why black holes are said to be perfect prisons until Hawking appeared in the scene. Before that, we would need to explain another term called event horizon, and I would say that this is like a prison gate. This is like a prison gate, this one, we can think about it, although it does not actually, there is no gate per se, but then we can think of it like a prison gate, and at the point at which the gravitational force precisely counteracts the light's force to escape it. So here, if somehow light reaches here, from here light cannot come out. So this is the boundary almost. The prison starts from there. So then this is the portion that is called the event horizon. So what exactly did Hawking contribute? So he said, he showed, until when people were using up till now, they use relativity, but relativity without using quantum mechanics per se. It was more or less the initiative of Penrose, and that quantum mechanics was introduced into the field to explain gravity. That he showed that there are possibilities that some neutrinos would veer towards the interior of the black hole, and in the process some other neutrinos which do not have with other spins will veer towards outside. There is a possibility that they will come out outside. So some particles will come outside. So this is what is said. So what does it mean? It means that from inside the black hole something comes out, some radiations come out. So initially we thought that nothing can come out from black hole, that it is a perfect prison. For the first time in 1970, he showed through combination of relativity and quantum mechanics that it comes out. Some radiations come out. Then he perfected his equations over the time again and again, and then he showed that not only these radiations come out, they come out, this is known as Hawking radiation, by the way. This Hawking radiation comes out, and they come out in streams, that is what he said, and then at some point of time all the matter would evaporate and would explode. That is at around 1990s he showed that it would explode, and that this explosion would lead to another kind of a Big Bang. Okay? Then the kind of work that he did in his PhD was that he introduced, as I said, after Penrose, he for the first time introduced the idea of quantum mechanics into the study of gravity along with relativity, combined both, and in that way he found that relativity is the process, and if we combine both quantum mechanics and relativity, then you find that there are numerous infinity terms comes into your equations, and he found a way of removing all these infinities from his calculations, and until he showed that one particular infinity or singularity will remain at the beginning, and he said that this is the Big Bang. So, one Big Bang is required to create the universe. So, he said it is the Big Bang which created the universe. So, big creation of the universe with the Big Bang was first demonstrated mathematically by using relativity and quantum mechanics by Stephen Hawking. So, that was one of the great contributions, and later on this Hawking radiation. These two are the great contributions of okay. So, in 1974, he shocks all his colleagues and the world by showing that black hole will leak and explode when quantum effects are taken into account. And 1976, he showed that while exploding black holes and randomness to the universe, forever erasing information of what might have fallen into black hole. So, there were numerous questions as to what will happen to the ideas of quantum mechanics, information, the ideas thermodynamics. So, these he considered, and he said that information, ultimately in 2004 he showed that information is preserved in black hole, and that but then the argument continues even now. In 1982, there was another thing that he did that needs to be mentioned to the physics students in particular, that Dr. Hawking and James Hartle, they proposed a model of self-contained universe that has no boundary in space and time. They considered an equation and which was more or less like a sphere, that it is self-contained. So, everything is within this space and time. So, if it is space and time both way, it is self-contained. In that case, if we ask, suppose when we start, he says it begins something. If it is considered like a sphere, and if you call it a north pole, not the north pole of our Earth, but the north pole of the universe. Suppose we think this is. So, this is the beginning of time, he said, and as we go towards, as time elapses, then we go gradually towards the below. And this is the model of the self-contained universe. Then he said that if we now ask the question, what is the beginning of time? What happened before the time, beginning of time? Then he said that these are meaningless questions, because the concept of North Pole, that is the point which is the maximum on this, and there is no meaningful, it is not a meaningful question to propose that what happened before. So, everything can be considered only within this finite self-contained universe system. So, that is why he used to say, after doing this calculation, that his idea that God does not exist, because you do not need this. So, these are the things, I will not go through all. So, then the question is, how do we know that black holes exist? Black holes are not, you do not allow light to come out. Nothing is seen. If nothing is seen, then how do we say black holes exist? So, this is a perplexing question, but then he answered. The first way he said that we can still, however there are a number of signs. Whenever there is a black hole nearby, we see clouds of gases revolving around it, and from the revolving gases or the revolving stars which rotates about something where you cannot see anything. So, it rotates about and there is no pulling force per se, then it was suggested that it came from black hole, that there must be a black hole, and it is holding the it is making the clouds of gases which called accretion disk to rotate, and which is why we are seeing all these. And there were also matter falling into black holes, and they were because of the accretion disk that the black holes have, and there is magnetic stress developed within that. Because of that, there is X-ray coming out of this, and this X-ray is coming out in large amount, and you do not see a source from where it is coming. So these are the likely places where a black holes exist. So these were, until then, these were all some sort of guesses, but then now people are able to measure even gravitational waves, and with the measurement of gravitational waves, it has been possible to show that these gravitational waves are coming in a manner which is consistent if we think that black holes are there. So that is why gravitational waves are more foolproof methods for studying black holes as it is. So in our Cygnus we know black holes exist, X-rays come about, there are clouds of gases. Now just for a matter of interest for students of physics, what happens once you fall in a black hole? Suppose you fall in a black hole. This is a problem which is almost given to the astrophysics students normally, but what happens? So this was done originally by, this concept was originally developed by Hawking again, and he showed that because in quantum mechanics there are this principle of superposition, he says that there are a superposition of two possibilities. What are those possibilities? One possibility is that the person, while coming to the event horizon, around the event horizon, that he will be burned to death by the Hawking radiation, and also the X-rays that are coming out, that will simply kill the person right there in the event horizon. And the other possibility, he says, that the person will go right across the black hole, just like a free fall. If it is a massive black hole, then the experience will that of a free fall, and it will go down deep into the black hole and towards the point where there is a singularity. Until that is reached, everything will go on very smoothly. The person will leave. So the question is whether the person is for a common man like us, the question is whether the person will be alive or is he dead. He says two things. One is, if it is inside the black hole, he goes on to live forever almost, and if it is outside, he is burned to death. So the question is like this, and we know this famous black cat experience, where there is one black cat is living and dead at the same time. Here also this question comes in, and we have shown, Hawkins has shown, that both these possibilities are consistent with the ideas of information, with the theory of thermodynamics, that everything is fine and no laws of physics is violated, but the basic question remains whether I will be alive or dead as I enter to the black hole. So these type of, and the debate goes on. Just by the way, we know if we have to talk about Hawking, and without his reference to his ideas on alien, it will be incomplete. He said that aliens, when they come, normally in our Hindi films, they are shown as if they are, and even also in English films, they are shown to be very friendly. But Hawking says that they will be very hostile, because if they have managed to come here after making such an effort to come here by moving through thousands and thousands of kilometers and making a safe landing here on Earth, then their intelligence must be much superior as compared to us, because we have not so far been able to go elsewhere. So their intelligence would be superior to us, and that is why he warned that this may not be a very welcome experience. And finally, on AI, artificial intelligence, we know there has been work going also in Tejpur University about artificial intelligence, and things are improving day by day. But then Hawking said, artificial intelligence at what point of time will be so intelligent that if you, it will reach a time, it will reach a point whereby it will be so advanced that it will outperform humans and become a new form of life, because it will be at that point of time it will not only surpass human intelligence, but it will also be able to replicate itself. That he warns that then the rule of the humanity in the world will come to an end. That is what his prediction is. So these are debatable questions and views, but then without stating this, the ideas will be incomplete. And another more important point which is suggested, that we need to find a way to go to another planet so that we can live, because as per his view, the world, we have already exhausted. Our esteemed Vice Chancellor is here and noted environmentalist, but he would know better. But then Hawking has said that this is already become not habitable. The world, the earth is no longer habitable, that it has already crossed the limit, and within 20, 30 years, if we do not find a way to go to another planet, then we are done with. So these are some of the views of the gentleman, and then I will end with 3 quotations, because this sums up more or less the essence of the person that Stephen Hawking was. That he said that science is not only a disciple of reason. We may mostly go to reason in science, not mostly, almost everything we decide on reason. Experiments, observation, that is observation, and facts, and theory based on reason. But he also says that this must also be coupled with romance and passion, otherwise new ideas will never develop. He also said that life would be tragic if it were not funny. That is, he said that life is very funny, we should appreciate it. But most importantly, he said it would not be much of a universe if it was not home to people you love. Normally, you do not find such utterances from a scientist, because he combines what he sees, what he observes, together with his observation of the society, what he observes in the society. So here was a new person. So that is why I would once again like to end with that what I said at the beginning, the lines which Redmayne read out from Ecclesiastes in the Bible, that to everything there is a season, there is a time. There is a time to be born, there is a time to die, there is a time to plant, there is a time to pluck, there is a time to weep, there is a time to cry, there is a time to laugh, there is a time to mourn. And we are here today to mourn the demise of a great person who has given us new understanding of life, new understanding of universe, and also showed us how to stand up in the days of difficulty. So with this, by paying tribute to this gentleman, I end. Thank you.
Sir, for this beautiful talk. We have surely learned lots of new things related to Professor Stephen Hawking's work, and we are grateful to you explaining lots of things like related to general relativity, space-time curvature, and compact objects, red giant, white dwarf, black hole, event horizon, and Hawking radiation in a very simple way. Thank you, sir.
Can there be some questions from students? Yeah,
Anybody has any question? If anybody has questions,
What is your opinion about the Earth is no longer a habitable planet? What is your opinion? Yeah. No, Hawking said that Earth.
I'm not an environmental scientist to answer that. But then I still believe we have not yet crossed the limit. Even if we try now, not everything has come to that. Hawking might have some set of ideas. I admire him, but then I do not agree with everything he says.
Sir, can I add to that? Because I do not agree with things in this method. Because if we cannot make our art livable, how we can predict that another art which is not already there's nothing and we can do something there. Already it is there. We have we have not done anything and we have spoiled there, and we are expecting that something is not there and we will do something. So I do not agree with Hawkins in this matter.
Yeah, I too do not agree, and I do not think we have a right to go to another planet and spoil it.
Any question for
Sir.
students?
Sir, I have one question.
Yeah, yeah.
So you mentioned the one.
Sir, you mentioned one paper in 1982 by Stephen Hawking and James Hartle. So in the paper, you mentioned that there is a self-contained universe. Sir, does it is consistent with the presently accepted flat inflationary delta CDM universe, or it does not?
Yeah, it is consistent with that, and because over the times he has revised his calculations. So in 2008, I believe, 2008, he showed the calculation which are inconsistent with these ideas. Yeah.
Thank you.
Any more questions?
Sir, is there any probability that black hole may enter in our solar system? Can we say like this?
I mean, yes, that these things happen. Okay, but these probabilities are of such nature that it can happen only after billions and billions of years ago. So, but then this is also true, and Hawking believed that systems and planets and then being recycled. So, universe teaches us to recycle.
Yeah, in physics we use this gravitational wave, that verification of existence of that. So it took so many years to verify. So likewise, Hawking's this Hawking radiation, whether it is been verified already? No.
Radiation from a black hole.
Yeah.
Yes, yes.
But that has been verified.
Yeah.
So is there any other thing which is not yet been verified, Hawking's ideas, and which might require some huge amount of experiment?
I mean, that experiment we cannot do. The beginning of the universe. I mean, after all, that is his theory. He has proposed it, and he has shown with mathematics, which is consistent with relativity and quantum mechanics. We believe it is true, but still we want to that sometime that it should be proved. But then there is no way we can do that.
So thank you for the wonderful talk. My question is, you just said that the Big Bang happened because of the explosion of a black hole. So was there another universe before the Big Bang? Was there another universe where the big black hole was present?
That is the problem. You see, Hawking said, I mean, I did not say that.
Because although I believe in these equations, because as a student of physics, I believe in relativity, I believe in quantum mechanics, so it is very natural for me to believe that yes, it should start with a Big Bang. Okay, but then what happened before Big Bang? Those ideas, Hawking has said that to ask these questions are meaningless. Meaningless because this is the space-time, confined space-time, self-contained space-time that we can talk about meaningfully in terms of the existing knowledge. So anything beyond, it is not possible to discuss meaningfully.
So can we imply that since there are numerous black holes right now at the universe, so can we imply that there is a possibility of another Big Bang happening very soon?
Yeah, that is what Hawking has predicted. Yes.
Thank you, sir.
So you talked about that black hole is so heavy and dense that it bends the space-time a lot, and very small gap is left, very small hole is left. What will happen even that hole diminishes?
Then it will be a place where totally governed by laws of gravity only. Nothing else happens for years and years to come.
Is there anything as such present?
No, nothing of the sort has been yet been seen.
Thanks.
Under the influence of gravity, time slows down. So, is there any chance that under the influence of dark energy, time may speed up?
I think Mrinal can only answer that. Because I do not work in that. Honestly, we do not know, we should not make comments where we are not very confident. And Mrinal Das is working on those areas, so probably he can answer. If you want to answer, you can. Okay. Is that all? Yeah, one more.
Good evening.
Good.
Particle physics, I don't know much about astrophysics, so I watched a movie called Interstellar. And there is a very interesting thing that scientists they managed to travel from one universe to another universe with the help of wormhole. So really want to read this. So do you think, sir? And what are
Again, I have to talk in terms of probabilities. And one student of Hawking, I failed to recall his name, he has shown that yes, that energy can be transferred from one system to another system of the universe through a wormhole, and within a very short. I mean, even if his conclusion was that even if somebody travels some particles travel the shortest possible time within a very short time, then it is possible through a wormhole. So these predictions are there. So theory predicts this, but we do not know whether it is really true.
So I have a question.
Yeah, I'm now scared. Because this gentleman I know, he was yeah, please.
Thank you for I have a confusion. It's confusion in the sense we talk about all the molecules, atoms, they are made up of a nucleus. And we talk about gravitational collapse. And let us go to the black hole. Now, what happens when all the atoms come together and collapse to a single? Now, these atoms are electrostatic in nature, electromagnetic in nature, they have charged particles. If they are charged particles, definitely there should be a force of repulsion. And there is a gravitational collapse. Therefore, there should be a moment where the force of attraction and the force of repulsion should compensate. Now, at this moment, still, if somebody falls in, what happens? In general, they should bang up, explode. But now the question is whether the same molecule or atom or nucleus exists in a black hole. If it does not happen, the explosion does not happen. If the same molecule or atom, the nucleus, or whether the particles are completely different and the real world, whatever we have measured.
So inside, there are two things. Inside, what happens inside the black holes are mostly because, as I said, it comes first we go to red giant, then white dwarf, then neutron star. So neutrality has already come into the matter. Then we are also talking about the Hawking kind of radiation. Hawking kind of radiation is not entirely from the inside of the black hole. It is mostly coming from the accretion disk. And in the accretion disk, yes, there are gases and molecules like the one we have. So there, from these particles are, different particles are created, and some here inside and some go outside. But mostly non-charged particles are created there. So even while going there, but outside there are lots of charged particles. And that is why I was expecting a question that I have been telling that light does not come out of black hole, and it cannot come out of black hole. If the light cannot come out, then how come X-rays come out? These X-rays actually do not come from the inside the black hole; they come from the accretion disk. Okay. So similarly, these particles are mostly outside the accretion disk. That is what is visible.
The nature of the particle probably inside a black hole may not be known for him.
Yeah, that is not known. But then the general belief is that it has lost all charges. Because neutrons and protons are not neutrons. Protons and electrons are all crunched because they come to a chargeless neutron state. And there is, as our esteemed Vice Chancellor has pointed out at the beginning, there are talks of this plasma. Okay, parton inside the parton, the quark gluon plasma thing that is inside the thing, but their charges are, so distributed that they are connected. All point out finally they come out as a total. If you consider them as a totality, they come out as neutral. So that might be the reason. I do not know, but then this is the general thing. Yes, one plus one ways is there.
Quark gluon plasmas that are probably the charged particles together.
But then, as I said, they constitute totally, if you consider, totally their charges. And they are held so tightly together. So things are not very well known. That is why there is so much of interest now in the study of this.
So that will be completely classical in nature.
Yeah.
I think we can continue the discussion outside.
Yeah.
Now I kindly request everyone to join us for a cup of tea outside.